In this video, we are going to cover the reason of convergence ROC, which is the important topic in the Laplace transform. We will also cover the properties and the trick to find out the ROC. आपको वीडियो पसंद आएगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए. The definition of ROC is like range of variation of sigma, which is the real part of the S, for which the Laplace transform converges is called ROC. If fs function is given to you, then the ROC will change with the value of sigma. अगर हम sigma की value को change करते हैं तो ROC भी change होगा. So in ROC we are going to see the direct effect of sigma in the region of convergence. We consider the property of ROC. The first is the ROC of the axis consists of strips parallel to the j omega axis in the S domain. So to discuss it, we have the validity of this property stems from the fact that ROC of axis consists of the value of S, that is having real part and the imaginary part, for which the Fourier transform of this function is going to exist. So the ROC of the Laplace transform of xs consists of those values of s for which this function is absolutely integrable. So that we can have this property, and since this condition depends upon the value of sigma only, the real part of the variable s. Second property is the ROC does not contain any pole. So to discuss this property, let us assume a function fs having one pole s plus 2. So to find out the pole, we can put s plus 2, that is equal to 0. So we have the pole, that is s is equal to minus 2. Now we can have the fs for minus 2 because the property says that the function should be finite. So we can put the value of s here. So this comes out to be 1 by 0, which is not a finite number and it is approaches to infinity. So if I am going to put a pole and have a pole into the ROC, the function tends to infinity by the definition we know. So the ROC does not contain any pole. Third property is if xt is finite duration and is absolutely integrable, then the ROC is the entire S plane. For that, if we can assume a function which is a finite duration function, the extreme time value will lie on the right side and the extreme time value on the another side is lying on the other side of the plane. Suppose we are having a function which is absolutely integrable, that xt function is there and we are representing this function in this way. So this function is absolutely integrable. If I am going to consider this limit of the function with absolutely integrability property of the ROC, that function will lie with this bounding condition on the left side of the plane and with this bounding condition lying on the right side of the plane. So these are the extreme points of the S plane. So next property is if xt is a right-sided signal and that is xt is 0 for t naught lies between t to infinity, then the ROC is of the form that real part of S is greater than alpha max, where alpha max equal to the maximum real part of any of the pole of the S plane. So to simplify it, we are analyzing it in this way that if the Laplace transform of xt is rational, then xt is right-sided sequence. The ROC is the region of S plane. So to understand it more clearly, we can have one sort of example that if a signal is there, say suppose we are having a signal like this, and it is having a right-sided sequence like this we are having. So right-sided sequences are those sequences which is having finite value on the x-axis till plus infinity. We are having certain signal. So we are having this right-sided sequence, and say suppose the system is having two pole on the axis. On the axis, two pole is having. So the one pole is on this side and another is on this side. So the maximum value is this. So if maximum value is this, then the ROC lying on the right side of this, right? So this is the ROC. That is the property is same. So another is if xt is the left sided, that is xt is 0 for t is lying between t to minus infinity, then ROC is of the form that real part of S less than alpha minimum, where alpha minimum equal to the minimum real part of any of the pole of the x-axis. So to again understand it, we have elaborated it already that if xt is left-sided sequence, the ROC is the region in the S plane to the left of the leftmost pole. तो हमें यहाँ पे leftmost pole पे concentrate करना है. So to understand it, we are again having a pole representation or signal representation that a signal is a left-sided signal. Here we are having yt signal, and again the definition says of the left-sided sequence, the signal lies between finite value of uh, of the x-axis till minus infinity. So that is the left-sided sequence. And suppose the system is having two poles. System is having two poles, and one pole is lying on this side and one pole is lying on the this side. So if the sequence is the left side sequence, then the plane is ROC will lying on this side. So that is the understandable property from this point of view. Now, if xt is a two-sided sequence, then ROC is of the form that real part is lying between alpha 1 and alpha 2. It means there is a strip of line that it is going to lying on the including the imaginary axis of the S plane. So it is overall understanding of all the property of the S plane. Now we are going to focus here some shortcuts. How to find out the ROC of a given system. So here we are focusing on the shortcut which is more important for solving the numericals. So first step is compare sigma with the real part of the coefficients of t in power of exponential term e. Second step is check if the signal is left-sided or right-sided, then the side less than sign or greater than sign between s and alpha. Alpha means the value of the coefficient. So for that understanding, suppose we are having a signal ft is given by e raised to the power minus at u minus t. So इसका हमें ROC निकालना है. तो t का मल्टीपल क्या हुआ यहां पर माइनस a. So the coefficient of t is minus a. So we have to find out the relation between sigma and minus a. तो ये हमने फाइंड आउट कर लिया. नाउ हमें चेक करना है कि हमारी लेफ्ट साइडेड सीक्वेंस है या राइट साइडेड सीक्वेंस है. So here the signal ut u minus t is given. So this signal, as you know very well, that this signal is represented because it is u minus t. So it is represented like this. On this side, the signal is represented. So it means this is a left-sided sequence. So we can say this is left side signal. So it is left side signal. So if it is left side signal, so the less than sign will come. So the less than sign will come. So that's how you can calculate it, because ut is left sided sequence. अगर हम ut u minus t को e से मल्टीप्लाई करेंगे तो ft is also a left sided sequence. तो जो इसका ROC आने वाला है वो ये आने वाला है. इस तरह से अगर आपके पास कोई भी कॉम्प्लेक्स प्रॉब्लम हो तो उसको हम सॉल्व कर सकते हैं और उसका ROC फाइंड आउट कर सकते हैं. न्यूमेरिकल सेक्शंस में आपको ये काफी यूजफुल रहेगा. आपको वीडियो पसंद आया होगा, आप लाइक करिए, शेयर करिए, चैनल को सब्सक्राइब करिए, बेल आइकन दबाना मत भूलिए.